We will find slope from a table. With our notes, what we want to do is make a table. We have our x and our y, so our coordinate pairs of 3, 7, 2, 4, 1, 1, and 0, -2. So we want to find, and we remember slope is the m, which is slope, which is the change in y over the change in x. And we always want to write this down with our slope whenever we do slope. It helps us organize our information and get the right numbers in the right place. So we have our slope, which is the change in y is in our numerator. So I'm going to put the number here for the change in y, which is, oh, -3. And if I go to the next one, that's going to be a -3 also, and a -3. So because this is our change in y right here in our table, that goes right up over here in our numerator for the change in y. That's what I love about the table is that it really tells you exactly what number's what. When it's on a graph, you have to know, well, the y's go up and down, so that means that that number has to go here. So now when we're we have to find our change in x, which over here, if we look at this, we have to be careful because our arrows have to go in the same direction as our other arrows because we went this way down with our arrows. So it's not just a line but it's actually the direction we're going. So from 3 to 2 is a -1. 2 to 1 is a -1, and 1 to 0 is a -1. So our change in x, that would be this one, which is our delta. Our change in x is a -1. So we substitute both of those in. Now we simplify it. I notice I have a negative divided by a negative is a positive slope. And 3 over 1 is 3. So our slope is 3. So now if we go to another example of another table, so this is example number 1. Example number 2. X and Y. I always like to put those up there because they really help me organize my information. So we have X is 10, 4, 22, and 30, 0. So if we take a look at this one, again, I think I'll use a different color just to help me kind of organize my thinking. So I'm going to start over here on the X's, which here are a +10, which I kind of like that. I like going +10, +10. It's a nice positive going up for the change in X. And the change in Y, we have to go down because our other arrow is going down in the same direction. So we have to continue that same direction here for our arrow for our change in y. So 4 down to 2 is -2, and 2 to 0 is also a -2. So we're going to use our slope, which we're going to write down again. M equals the change in y over the change in x. Or if you like to use the rise over the run, you can do that. But I myself really like the change in y because I can see my y here, the -2 is my change in y. So we have to be really careful making sure that we get that -2 in the numerator because of that y, that change in y. My x is a +10. And I know a lot of people leave that plus out because they just know that every number is positive if it doesn't. But for me, I like to put it in here with my slope because I know that I'm going a -2 and a +10, which is a negative slope. And then I can simplify my 2 and my 10. 2 goes into 2 once. 2 goes into 10 5 times. So my slope is a positive, or sorry, negative 1/5. So it's a negative slope. So that means that my slope on my graph is going to go down. Now, I want to think about that slope. Is it going down shallow or down steep? So I kind of look at my rise and my run. So my rise is my y value. So I have a 1 change, a negative 1 change for my change in x, which is a positive 5. So that means that I'm going to go down 1. I'm going to go down 1 and positive 5 over here. So that means it's going to be the shallow one because it's going to be, it doesn't, this steeper one is down, would have to be like down 5 and then over 1. So that would be a different slope. So that would be the 1/5 would be that shallow one. So now how does it get a little bit more complicated? So we're going to go and look at when we have problems when we're given two coordinate pairs. So if we have -4, -1, and comma 2, 1. So we're going to look for this slope in between our 2 points. So some people find that the formula y sub 2 minus y sub 1 all over x sub 2 minus x sub 1 is they just substitute it in. But I find that if I put these in my table, which is what a coordinate pair is, it's just a table, or a table is a coordinate pair, and we can go back and forth. And I'm just going to put them in my table because it makes sense to me to put it in there to organize my thinking. So I'm going to go looking at this one from -1 to 1. My change in y is a positive 2. So that when I substitute that in for my slope, it's going to be a positive 2. And then this one's a little trickier. So I'm thinking about a number line. I'm starting at -4, going up to 0, which is 4, and then up to 2, which is another 2 to 4 is 6, and it's in a positive direction. So that means my x is a positive 6. So I'm going to write down my slope, which is the change in y over the change in x, which equals my y then is here with a change of +2, and my x is a +6, so that means my answer is going to be a positive slope, so that means it's going to be going up, and 2 goes into 2 once, 2 goes into 6 3 times, so my slope is 1/3, and it's a positive 1/3 slope. So that means I rise 1 positive and run 3 of those positives. So this one's going to be kind of a more of a, again, a shallower one because my change in x is longer than my rise there for that one. So we have 2 more examples, and these are our special cases. So if we take a look at, we're at number 5, and we'll go back to our table and find that slope from a table, 2, 6, and 10, and y is 4, 4, and 4. So 2, 4, 6, 4, 10, 4. Those are our points. And then when we go to, something's funny here because from 2 to 6 is 4, but then I'm thinking over here, 4 to 4, oh, that's just, we have a number for that. That's just 0. I put a plus, but 0 is neither positive nor negative, so we're just going to put 0 in for that one. And we can see that here it is also 0. Some people like to put a +0, but you could do either or. And this one's a +4 for our x. Our y is 0. So even though it's a 0 number, we still write m equals the change in y over the change in x. And where does the 0 go? It goes in the numerator because that is the change in y. The x, which is on the x side, is 4 positive. And 0 divided by any number is 0. So our slope of this one is 0. And we do have a number for that. Now comes the trickier one. So for this one, number 6 example, we'll be given it as a coordinate pair. So -3 comma -3 and -3 comma -5. So I'm going to create a table for this. Because for me, when I have coordinate pairs, it's easier to organize it as a table to kind of help my thinking. So -3, -3, and -3, -5. And I'm going to have to find my slope. So I'm going to set up my slope right now. M equals the change in y over the change in x, making sure we write that down each time, and which will help us get the right answer. So I'm going to start over here on the y's. So this time I'm going to go down from -3. I'm thinking on my number line. So thinking on a number line, I'm starting at -3 and I have to go to -5, which is further left. So starting here and going left 2, so left is negative. So -2. This is the tricky part with these problems is sometimes they're positive, sometimes they're negative, but this is a -2 because we're going left 2 down the number line. So if we were starting at -3, going to -3, there's my 0. So you would think that this would be a slope of 0, but where is our 0? It's in the x, in the change in x. The y is the change of -2 for our y. So -2 goes on the top, 0 goes in the denominator, and if we have any number divided by 0, that is undefined. So the answer itself is undefined, not this number over here, this fraction. That's kind of what happens up here with all of our other ones when we had a number, but because this is one of our special cases, undefined is the answer. Notice how I circled it, or I put the answer, just like I would do with the 0, slope of 0, I would circle that undefined slope.